So, in this section, we're going to introduce a new topic which is called graph theory, which is a very useful and interesting branch of mathematics. Now, one of the first people to experiment with graph theory was a gentleman by the name of Euler, who lived in the 18th century. And he attempted to solve a very particular problem: how to cross 7 bridges onto an island without using any of them more than once. Okay, now from that point on, the study of graphs has been applied to a large number of real-world problems. Uh, they are all around us. For example, urban planning, road networks, uh, shipping lanes, computer networks, and so on. And also, if you consider it like things like social media, would be characterized by the use of graph theory. Here's a very simple example here. So we have New York, Dublin, London, and Cork. And this is a graph of flight networks between a group of airports. Now, there's two things I'm going to sort of mention here first. There's two characteristics. First off, we have these points here: Dublin, New York, Cork, and London. Now, the points we're going to call vertices. And then also we have the lines that connect these points, and we are going to call these lines edges. Okay, and so we actually sort of like associate the letter V with vertices, and we're going to associate the letter E with edges. Okay, so that's an important point: vertices and edges. That's just to get us going. Now, an example of a multigraph. This is just something I'll bring into play later. I just have the graphic here. So this is a graph. It's got vertices. It's got edges. A couple of things to remark upon here. We have a vertex that is on its own. And also, just as another remark here, we have a vertex with an edge that just connects back to the same vertex. Okay. One more thing is, actually, now that I think of it, see it, is that there are two edges between A and E. Or A and C. Now, so a path from vertex V0 to vertex Vk is a sequence of vertices and edges. Okay, so where for each eye the endpoint of edge E1, EI are Vi minus Vi plus 1. Okay, essentially that's a very thick mathematical definition, but a path is essentially something like this. So I'm going to name these edges. We have the vertices named here, but I'm going to name this edge. I'm going to call this 1. Actually, I'll use green here. I'll use that. Call that 1. This edge here. Call this edge here 2, and I'll call this edge here 3. So essentially, what we can say is the path from A to C, a path from A to C that does not include any of the two ones I mentioned previously. We will start at A. We use edge 1. We would be at F. Then we'd use edge 2. Then we'd be at B. Then we'd use edge 3. And then finally we'd end up at C. So that's a path. The length of a path is the number of edges it contains. If an edge is used more than once, it is counted each time it is used. Now, this actually gets a bit more complicated as we go, but we'll just take a very simplistic approach here for the time being. Later on, there'll be more things to consider. Now, what is the length of this path, the one I've just described here earlier? Well, we use this edge here, this edge here, and this edge here. So the length is 3. 1, 2, 3. Couldn't be simpler there. Now, a graph is connected if there is a path from any edge to any other edge. Now, let's look at this previous one here. This one is not connected. This graph is not connected because there's nothing connected to E. E is not connected to D, it's not connected to A, it's not connected to F. You cannot, if you are bound by these edges, you cannot reach E. So it's not connected. A cycle in a graph is a path from one vertex, from some vertex V0 back to V0, where no edge appears more than once in the path sequence. Now that's when I said things are starting to get a little bit more complicated there. V0 is the only vertex appearing more than once, and it only occurs at the ends. Okay. So let's look at a cycle here. So we've discussed this path here from A to C. What I'm going to do here is add in one more edge. I'm going to call this edge up here 4. This one, oops. Let's do that again. I'm going to call this edge here 4. That one there. And if we go from C back to A, that would be a cycle. So 4 and A. The length of that cycle, as a matter of interest, it just continues on from the same notion that the length of that cycle will be 4. Okay. So the next point we are going to talk about is a graph with no cycles is acyclic. Now, if up in the corner here, I'll just draw an example of an acyclic graph. So we have an edge there to there, and an edge from here to here, and another one from there to there. So it's essentially a sort of star. Now, in that example there are no cycles. You cannot get back to the same place use it from a cycle, as in you cannot use any edge more than once. Alright, that is the first set of definitions. V1, E1, V2, okay, that's very similar to something I mentioned earlier. Now this is an important topic here, is complete graphs. So the following picture represents simple complete graphs with 1, 2, 3, 4 vertices. And the simple graphs with n vertices are denoted Kn. Okay. Now, just let's look at some things here. Simple graphs. What is the definition of a simple graph? A simple graph means that there is only one edge between each vertex. So previously we looked at that example where we had two vertices that is connected by two different edges. We've seen something like this previously. In this case, that would disqualify the graph as being simple. So that in this case, between each edge, there's only one vertex. Between each pair of vertices, there's only one edge. That's a simple graph. Now, a complete graph is also something to be considered. In a complete graph, every vertex is connected with every other vertex. And for example, here, the 4 vertices are all connected directly to each other. That's the idea of a complete graph. And we would denote complete graphs Kn. Okay, where K would be the stand for complete, and the subscript n just indicates the number of vertices. So down here we have K1, K2, K3, and K4. Those are some simple ones. Now that's the first part of the presentation over. I'm going to set up for the second one.